Good day everyone, you are welcome to my channel, Physics and Chemistry Simplified. In today's lesson, we are going to be looking at dating atomic theory and its modification. So in the subsequent lesson, particularly the next lesson, we are going to be looking at atomic structure and we're going to be doing justice to some small calculation theory. But in today's lesson, we are going to be looking at dating theory and its modification. Dating theory was postulated in the year 1808 by John Dalton, and the law states as follows. Number one, matter is made up of small, indivisible particles called atom. It's made up of indivisible particles called atom. That was the first law. The first theory. The second theory, atom of a given element are all exactly alike. Atom cannot be created or destroyed. Number four, atoms combines in small whole numbers. So those are the theory that was put forward by John Dalton. So what are the modifications? Why are these laws not standing again? What are the modifications to this theory? The first theory, matter is made up of small indivisible particles called atom. This is not acceptable because of what? Because of radioactive elements. There are some radioactive elements that they are now dividing what? Spontaneously. For example, radium. Radium can disintegrate into two noble gases known as what? Helium and random. So that is the reason why that law or that theory is no longer acceptable again. Number two, atoms of a given element are all exactly alike. The theory also, or the law, or the theory anyhow, is not acceptable because of what? Isotopy. It's not acceptable because of what? Isotopy. And what is isotopy? Isotopy is the existence of an atom in two or more form having the same what? Chemical properties but different what? Atomic masses. So a typical example of an isotopy is chlorine. Chlorine has an isotopy 35 and what? 37. When you look at them, the atomic number is the same, but the atomic masses are what? Are different. Though they might have the same chemical properties, but the atomic masses is different. So as a result of this, we can now say, due to isotopy, the second theory by John Dalton that states atoms of a given element are all exactly alike is no longer what? Acceptable. The third theory, atom cannot be created or destroyed. Atom cannot be created or destroyed. This law is only applicable in a situation whereby atom, in a chemical reaction, whereby atom react as a single unit. But as a result of changes caused by atomic fission. As a result of changes caused by atomic fission, we find out that the atom of the element involved in these changes is completely destroyed. It's completely destroyed. Not just completely destroyed, their nuclei is broken into two or more simpler forms, thereby creating more simpler atom. So as a result of changes that are caused due to atomic fission, this law is no longer acceptable. It's no longer acceptable again. And the last one, which is atoms combines in small whole numbers. When you look at this law, you see that this law is only applicable in what? In inorganic chemistry. It's only accepted or applicable in inorganic chemistry. But in organic chemistry, for example, whereby carbon can form a very large complex organic compound. And when carbon form this complex organic compound, are they going to react in small whole numbers? No, they are not going to be. They are not going to combine in small whole numbers. Something like this. When pentane, for example, when carbon form this compound, this is a complex organic compound. Are you expecting this compound to react or combine in small whole numbers? It is not. So this number 4 law is only applicable in what? In inorganic compound, but it's not applicable in organic compound. This brings us to the end of today's lesson. In our next lesson, we are going to be looking at atomic structure and some calculations that are involved inside atomic structure. Please do well by subscribing to our channel. God bless you, and don't forget to on the notification button. See you in our next class. Peace out.